Utsukare.
Hello, Professor Kasayar.
Hello. How are you doing today?
We are with cold today. It's cold here. We are waiting some participants to arrive. They come from the hotel.
Okay. So it's Christmas. It's almost Christmas, so you should expect some cold, right?
Yes. ¿Alguien quiere hablar con él? Pues yo diría que ya, ¿no? Okay, Professor, we are ready. Wherever you want to start, it's okay.
So I'm going to share my screen. Okay, so I need the right to share my screen.
Yes, please.
It doesn't allow me for now.
Okay. Give me a second. Okay, I think it's ready.
Share the screen. Share sound. Share.
Okay, we can see now your presentation.
Amazing. Hello, everyone. My name is Kash Misarian. Today, I'm here to talk about aging and age tech. And together we investigate some aspects of the age tech that is a bit neglected. The title of the talk is Preventive Age Tech versus Falling. In about a few minutes, I'm going to explain why I added this prefix to the age tech, and I'm going to make more sense. So we are experiencing the aging crisis in the world, which is literally the worst in the history of civilization. we are experiencing the highest rate of life expectancy in the history, which is 73.2 in the world. And in numerous countries, this number is more than 80 years. So if you want to compare it to 20 years ago, which was like 65, this number gonna instigate some serious trouble for the years to come. Just to give you an example, 65 people over 65 will be 2 billion by the year 2050. And to our surprise, right now there are 1 billion. So it's gonna be a double in 30 years. And also, they are the fastest growing age group. And the reason for that is that the life expectancy has been going up for the reasons like now technology is providing more resources for vital resources, like for technologies to provide food, or health and medical advancements are making human beings to live longer. And that's why you see that the 60, and on the other hand, people are not procreating as they used to before. And that's why you see these numbers. So what are the ramifications of this fast growing age group? There are three major ramifications. So this crisis imposes, first of all, life expectancy versus health gap. So what do I mean by that? So people are living a part of their life healthy and intact, but they expect to lose their health to some degree after a certain age. And this gap, this years that people are basically not living their best lives and they're not healthy anymore, now is going to be longer, which means they're gonna need more medical attention, medical care, and lots of expenses. The other thing is the wealth gap. So all the provisions up to this date was about, okay, everybody pays to their pension, that I expect to, have money after their retirement. But all those provisions were based on previous numbers. And all the money that has been provisioned to be saved was for a certain lifespan after retirement. But now there are several years and extra years added to this lifespan. And what we expect is people gonna have monetary problems because they're gonna live longer than they unfortunately hasn't been predicted, and now they're going to be out of money. Well, all these two problems aside, there's like a bigger problem coming human beings' way, and that is the caregiving gap. So Japan is having the biggest population of older people. It's like 27% of the population is over 65. What happens, or let's say is about to happen, is like in 40 years, the ratio of the people who can work and provide care to the people who are 65 plus and might need care, most of them, is going to be like 1.2, which means for every older person, there's only one person who can give them some care. So the definition of geriatric care that we have today won't last anymore. And there has to be like some serious redefinitions coming up to basically avoid the crisis. One thing that is obvious is in the future, one caregiver should take care of more than just one care seeker or older adult. And the only way that this could happen is to unburden him or her with all the technologies that could assist this person to do the chores and tasks that make him capable of taking care of like multiple people, because it's not going to be like the traditional way of one nurse taking care of one older person, helping them with the chores, taking showers. No, that's not going to be like that. So we need technologies to do these things, do these chores for the older adults, while that person is just managing these technologies. Well, the domain that relates existing and emerging technologies to aging needs and objectives is called gerontechnology. But if we want to get more resolute, the digital technology that revolves around aging needs and objectives is called age tech. So don't get me wrong that I don't mean like the conventional age tech that we all expect and digital technology that we all expect to happen. Oh, like this, there's the wearable to do this, there's something to do that. There are like several institutions in the world that are actually trying to outline what are the upcoming challenges of the aging people. And there are like 3 major institutions: Aging 2.0, Agewell Canada, and there's a task force from the US that they try to delineate what are the challenges of the upcoming silver tsunami. And all of them basically have unanimously agreeing on these 6 challenges. One is the financial problems of the aging people, how to make their pension last, how to provide financial products for them to, face the new world while they're retired. Obviously, health, cognitive health, which is like very important. Social and connectivity, which means that how in the new age, when everybody's busy and like living far from each other, they can still connect and socialize and not be secluded to their like assisted living facility or nursing home. The other thing would be mobility and transportation, which means this might sound trivial to people who don't have mobility issues, but going and buying something from the near store is a challenge for a person who's suffering from aging issues. This is one important issue that should be taken care of. And the other thing is activities of daily living, taking showers, doing chores, taking the trash out. Again, these sound trivial to people who are not having those issues, but these are the things that should be solved with digital technology and age tech. All being said, this delineation, this outline seemed like, oh, these are like facets that should be tackled like separately. But if you look into the literature and take a closer look, you'll see that these challenges are super interrelated. More importantly, cognitive health basically is critically related to all of these aspects of age tech challenges. For example, it has been shown that crystallized intelligence is very important for keeping up with the finances in the older people so the people who are suffering from different levels of cognitive decline, when they have their crystallized intelligence compromised, they cannot keep up with it. So you see the relation between cognitive decline, cognitive health, and finance. Social and connectivity, it has been shown that if people do not have social activities and connectivities, that's gonna precipitate their cognitive health. And it has been shown that different sexes and different group of people needed different types of social activities to keep up the cognitive health. This is true that there has to be a combination of cognitive training, exercises, and social activity to keep the cognitive health from declining. When it comes to advanced activities of daily living, a Brazilian study has shown that people who are suffering from cognitive decline, they are capable of doing a significant less amount of number of advanced daily living chores. So as you see, whatever facet, whatever feature I'm talking about, it is directly connected with the cognitive health. Well, it is not a secret that geriatric trauma is something that is like a major threat to the aging population. To give you an example, 25% of all the trauma admissions in the US hospitals are geriatric trauma. And that constitutes like the 5th leading cause of mortality in the older adults. These traumas, are ranked. First is the falls, second is the motor vehicle accidents, and second was the burns, like they burn in the shower, they cannot take control of the situation, and that's going to lead to trauma and unfortunately mortality. Well, it's just not limited to the US. It has been shown the falls are ranked number 1 in Japan, according to the Japan Trauma Data Bank. And these are the 7.7 mortality rate in 65 to 79. And you see 6.6% mortality rate in the over 80. And the reason is the over 80s are not as mobile as the 65 to 79. So that's why you see more mortality rate in the people who are younger than 80 plus age group. So it should be considered that, as I mentioned, cognitive decline has to do a lot with these traumas, especially falls. So we can say that one of the biggest culprits of falls is the cognitive decline. Although there are like lots of claims that, oh, we are trying to prevent the cognitive decline, that's true, they can slow it down, but it is very common for almost all older adults to suffer from mild to severe cognitive decline. That constitutes MCIs, which means like mild cognitive impairment, which is just aging, and to like different types of dementia. What happens, to rationalize why cognitive decline is very, very correlated to the falls, I give you like reasons. One is like the sensation of stimuli gets diminished as aging happens. So like older adults are not capable of sensing as they used to. For example, when it comes to tactile sensation, higher frequencies are not making much waves for an older adult compared to a younger one. So they're losing certain bandwidth of sensations. Also, there's going to be like weakened neurohumoral responses, which means that like neural hormones pathways are not going to be activated as they used to. And the activation is going to take longer. There's going to be delays, and they're going to be less effective. On top of it, the comorbidities like diabetes may cause proprioception loss. Like proprioception loss is like one of the most important sensations that restores balance. And some people who have diabetes, they're going to lose it. So we are talking losing the bandwidth of connecting to the outer and real world. So it is natural to say cognitive decline directly causes higher risk of falls. Going back to the age tech, right now in 2022, there are 200 companies and startups that are providing services and products for the 6 challenges of the age tech. But what do they have to offer for falling? Here are 4 categories that they are contributing. First of all, and the most famous that all of us have heard of, is fall detection and calling for rescue. I think you heard of Life Alert, Apple Watch, but there's also new startups called like Safely You, Chirp, VR Care, and Nobi that they're offering variations of fall detection. But it is just basically if somebody falls, they're going to call for help and they come and take them. Here's the thing. It is very important to have a fall detection system because the longer that person, the fallen person, is being unattended, it's going to accumulate more harms and defections. So this is a very good way to cut short those losses. The second category is balance training. The balance training with like different gadgets. So normally we are facing a scale or electronic device that people get to train their balance with, and it gives them biofeedback and they become better and more aware, more trained, and they gain new skills to gain and regain their balance. ZBrew and Nimble are the successful examples of these solutions. The other very innovative offer. Somebody is not mute. So another innovative solution that has been offered is to give functional fitness training to older people through digital platforms. For example, like in-home training, to functionally make them improve balance, strength, and flexibility. Basically, the muscles that are not working, through the exercise, they can deploy other muscles to regain strength, to maintain balance. And the last category are basically airbag wearables. So I'm talking about like belts who are acting like airbags when somebody falls. So the idea is to reduce the impact. I'm sorry, could you mute? There is like somebody's not muted and I can't hear myself. So what is obvious is fall detection cannot stop the hips from breaking. Balance training and functional fitness training might ameliorate the cognitive decline, but they cannot stop it. And the fourth option, airbag wearables, might backfire and only changes the form of injury. So as you know, I mean, even in the car airbags, if there are conditions that airbag causes the injury to be even more serious. So what is the missing piece from a comprehensive fall solution here? What is missing is a solution that compensates for the effects of cognitive decline. So all the cognitive aspects of cognitive decline that I talked about, we need some solution that counteracts and counterbalance those shortcomings. Like this is a healthy brain that can predict what happens and can deploy in time the muscles to regain balance. But in an aging person, we are having less cognitive abilities to regain that balance. To be more precise, let's take a look at predictive cognitive processes. Predictive cognitive processes are very critical to balance recovery. What do I mean by that? I mean, when there are no predictive means to sense, recovering balance, even for a healthy young person, is way harder than they have enough sensation of what's about to happen. And I mean prediction. So it has been investigated what are the aspects of predictive cognitive processes that happens when we want to regain and maintain balance. Here I delineate like 5 phenomena that explains how human beings can maintain balance in the face of perturbation, especially big perturbations. Central set, dynamic prediction of sway, and internal prediction model, and finally, affordances for action. These are the titles of those processes of predictive cognitive in the brain that happens, and they are the only way to explain why somebody can maintain balance in the face of a big perturbation. So we need something to circumvent these weak sensations and delays. So what are the plausible solutions for that? Well, something that comes to mind is combining optical and non-optical real-time position motion sensing with algorithms that could predict fall before the onset. So I'm talking predicting, and giving some feedback to the person, basically acting in parallel and give them biofeedback so they would be able to use their existing resources to maintain balance. Why is that? Why could that help? Well, it is an auxiliary to the decline cognition. Given what I already explained about cognitive decline and its relation to falling, this type of solution, what it does, first of all, it circumvents the delays in the neural systems, the hormones that are not activating as fast as before, because it is doing its job independently in parallel. The other thing is, I talked about losing the bandwidth, like losing proprioception. Now we are basically adding more sensors to this person. So we are basically expanding the sensory bandwidth. It is independent. It does not affect it by the cognitive decline, so it can only help. And more importantly, if it does its job in time, in a timely manner, now it can provide more time for now slower neurohumoral activation. So if it can predict it in advance, there's going to be more time for a slow neurohumoral activations to react and basically maintain the subject's balance. Fast forwarding to modern ML methods, because this crusade basically started in 2000s, and the trendy machine learning methods of those days have all been used, like SVMs, Markov chains, hidden Markov chains, all has been tested and studied and investigated to detect falls, basically. Well, of course, they wanted to predict it because, like, the nature of Markov is to predict things. But they were not as successful up until now that deep learning revolutionized the domain of machine learning. And recent studies who tried and made effort to do fall detections are as follows. So there's like a group of studies who are CNN based, but as we know, CNNs are predicated on images. So they are relying on the images of falling. And of course, there are tricks to, use the video sequences to teach them how. To teach them, and they make them learn the falling against non-falling. But what they have accomplished so far is just the detection of action, including falling. So we are not talking prediction here. They cannot tell in advance that somebody is about to fall before it happens. Don't get me wrong, there are some studies who actually try to do a prediction. There was one in 2014. They used SVM, but they kind of synthesized the action of falling with a depth camera. And what they've done is, in their data set, they got good results from falling from a chair, which is a very limited way of falling. And personally, I don't think like only 45 videos of falling can provide a very comprehensive solution to the following problem. Later, there was also a combination of LSTMs as an RNN and CNNs to basically enjoy the both worlds. High capacity of pattern learning from the CNNs combined with spatial temporal information learning power of RNNs. This also had a very good results for detection and not much for prediction. There are some, so the reason is these are like our supervised algorithms, and because they are deep learning, they are data hungry, and we don't basically have like thousands and thousands of falling videos, natural falling videos to train these models. Of course, if there was the data sets of this sort, they would have, it was possible to do prediction, but that's not the case. There's the sparsity problem and actually having access to the data. The other solution is unsupervised methods, like autoencoders that could identify some anomalies in the upcoming input, but so far there are no studies who shows like tangible success. So what's happening right now is almost all the efforts are inclined towards deep learning methods. Maybe it is time to look into other methodologies until we have enough data to deploy and utilize deep learning solutions. I can give you just one example to basically explain what's my purpose of saying that we should resort to other solutions. Well, take a look at Swiss cheese model. It is famous for modeling of accident causation. So they use it for COVID. I mean, that's how countries came up with strategies to basically stop the pandemic. They use it for stopping ships to collide, and there are many applications in the world. Like what it does is basically it takes a system and it assumes some layers of barriers against failure for that system. They kind of liken these layers as like Swiss cheese slices because they have holes, and that's the imperfection of that barrier. And these holes, these imperfections are dynamic perfections. So they are moving in this barrier. So it's a changing flaw that is dynamically changes. So there are some barriers against failure from the system's point of view. But when these flaws, these holes are aligned, there's a chance for the hazard to go through. And when this happens, the system produces failure. So this model, if we can model the system through Swiss cheese model, what we can have is to see the probability of these alignments and come up with solutions to stop it. And also in dynamic, when you look at it like in the time lapse, you can predict, oh, this is probable to happen soon. This failure is probable to happen soon. Now, how about we take this approach and apply it to human gait? So now we think of human gait as a system that has barriers against failure, which would be falling. If we can model this with the Swiss cheese approach, what we can see is like, okay, these are the flaws and they are changing because we are monitoring the situation. We're supervising, there's surveillance of the situation temporarily. And we see, okay, this hole is aligning with the other hole. So we can say like there's this amount of chance that the failure happens. But the good thing about this modeling is we should, if there's like a model that can estimate those barriers and their flaws in a timely manner, what happens is we're going to have different models for different individuals, which basically mean, and that's just sounds normal, that every person falls because of different reasons. And if this model can assess and can estimate those barriers, the solution, the predictions going to be tailored to that person. So what's the other upside of this? Now we can come up with provisions to add barriers for that specific person to do certain things, to act certain way, or use certain things to reduce the probability of the fall. Well, this was just an example of the other approaches than deep learning for less data hungry solutions. And there are many that I would suggest that the people who are active in this field should go after. So thank you for listening and your attention. I'm here to answer any questions.
Thank you very much, Professor, for your talk. Do we have questions from the audience? ¿Alguien tiene preguntas? Pueden ser en español, las traducimos. Are you able to hear the question?
Yeah. It's a bit far, but I think I try to understand.
No creo que no escuche. Hello, are you able to hear the question?
Yes. Yes.
Hey, Kash, can you hear me?
Yes. Yes. Clearly.
Can you please give a timeline for these kind of products when we are expecting to have something like that in the market? And the second question is an advice. We are in a physics and mathematician actuary faculty here. So if you are a student right now, what's the opportunity here to do something in the future?
Well, the value, like we are active in the Japanese market right now. And according to the Japanese market, I'm just answering the second question first, my bad. But just want to give you an example of the value of being active in this field. We had like an investigation about Japanese market, and we showed that only 30% of decrease in the percentage of falls that leads to hospitalization, only 30%, has 60 billion yen value each year. So the market is like basically 3 times bigger if somebody can make it like 100%, which is not possible. But only 30% can reduce 60 billion yen, which can be deployed and contributed to other aspects of aging care, which is a crisis in the Japanese upcoming silver tsunami. So having a solution, having a technology, coming with an IP that can help, like helping the people not to fall, not detecting or ameliorate the impact. You see that there's a difference. If the hip is not broken, there's value. If it's broken, still the 60 billion has to be paid. So what was the first question? I forgot, sorry.
You went for the first. The second was like advice for students in the future in this field. How do you see it? Opportunities for physicists, mathematicians, actuary.
So I think I answered this question, but now I remember the first question.
The timeline for the
timeline. Yeah, it was about the timeline. So our company is an example of providing a solution of this sort. And we are looking into having entering an executive mode in 5 years. So there are other competitors in the market, but they're mostly, again, doing detection. So this is a very blue ocean market. So the prediction and cognitive aids, basically compensating. I'm not talking about just falling. There are like so many challenges that are related to the cognitive decline. And anybody who's contributing to basically counterbalance the cognitive decline, I would say between 5 to 10 years, there's going to be like a huge stream of revenue. They're looking into a huge stream of revenue. That's going to just expand through different countries.
Okay. Any other question? No? Okay. I think that will be all. Thank you for your participation, Professor Kasayan.
Thank you very much for having me. And I have to thank the administration of TEHI, especially Dr. Lugo, for giving me this opportunity. It was an honor, and I was humbled to be here with you. And thank you very much.
Thanks.
An assistant professor and electromechanic department at TEHI. His research group focuses on novel sensing platform for environmental, biotechnology, and health application. His research interests include biosensor and bioelectronic, smart sensor instrumentation, and signal processing.
Okay. One minute, Professor. We are trying to give you the control.
Okay.
Ok, pero ¿cómo lo quito? Okay, we are ready. You are in the main window.
Thank you. Can I start sharing my screen?
Yes, please.
Okay. Let me know if you can see
Yes.
in full view. It's okay? Full screen view?
Yes, it's full view.
Thank you. So let me know when I can start. I can start now?
Yes, you can start now.
Thank you very much. Thanks for the introduction. I really appreciate the invitation to give this talk in this conference. Well, I will give you an overview with some promising results regarding a novel bioimpedance soft sensor using an adaptive estimation algorithm. Altogether, this finding could be interesting for the community working on wearable systems for health monitoring, mainly based on electromagnetic waves. The talk is divided in 6 points, starting from a brief introduction on bioimpedance phenomena and its measurements, the contribution of the proposal, following by the implementation details, and finally I will present some results and the conclusion derived from this work. Well, let's start with the basics on bioimpedance. Electrical bioimpedance is a non-invasive non-invasive technique that provides relevant physiological information about the properties of biological media. Sorry. Okay. Bioimpedance can be interpreted as a physical model of the electrical properties of biological media. Particularly, bioimpedance is a measure of the change in the permittivity and the conductivity properties in the presence of an electric field at an arbitrary frequency. Hence, changes on electrical properties are due to the fact that biological media are dispersive. That is, its properties change with the frequency of the applied electric field. Now, interestingly, bioimpedance analysis is limited in the frequency range below gigahertz, such that biological tissues can be modeled through lumped parameters electrical circuits. Therein, the resistance is associated to the conductivity, whereas the capacitance has a narrow relationship with the permittivity of the media. It is important to note that the larger the electrical field frequency, the greater the penetration depth through the several tissues is. So, for example, in this picture, we have a 50 kilohertz current. So, in theory, or bioimpedance theory says that electrical field lines could penetrate through the skin, but could not go inside the cells. So, some applications in bioimpedance. Recently, this technique has gained more and more attention due to its versatility, such as non-invasiveness. It is non-ionizing, is low cost, and feasible to develop portable and wearable measurement devices. For instance, the applications are mainly focused on developing health diagnosis tools at the cellular level, biosensors for detecting nucleic acids, pathogens, proteins, and organic compounds. Also, bioimpedance has starting to emerge in neurophysiology, and bioimpedance-based plethysmography is an attractive method to measure vital signs, hemodynamic parameters, and respiratory processes. So we have a lot of applications in which bioimpedance is ubiquitous now, but despite the successfulness, several problems remain open, paving the road to develop technological advances. For instance, we need real-time measurements that are not straightforward with classical devices, which in turn are not cost-effective. Also, deploying methods to retrieve reliable data remains challenging. Thus, it is devices to have Internet of the Things sensors, smart sensors, in the basis of bioimpedance. We have here some examples, illustrative examples of what is expected to develop on the basis of bioimpedance. So, how do we measure bioimpedance? Well, we have several configurations, but the most useful is the 4-electrode configuration. In practice, this is done by measuring a potential drop across two inner electrodes in response to an alternating current excitation at the outer electrodes. And to quantify bioimpedance, the bioimpedance of the biological media, several techniques exist to retrieve either the real and the imaginary components, or the magnitude and phase of this complex quantity called bioimpedance. The available techniques for measuring this electrical quantity are the Fourier transform base analyzer, the amplitude and phase detector, and the synchronous demodulation. Among these, one of the most versatile is the synchronous measurement, owing its robustness and ability to deal with noisy data. but has some drawbacks in terms of its hardware implementation. So if we focus on this synchronous demodulation measurement, it considers a signal treatment stage where the real and imaginary components of the signal of interest can be extracted by multiplying it with an well-known frequency signal and its 19-degree shifted version. Ends by simple trigonometric relationships and deploying signal filters and multipliers, we can retrieve the complex voltage in terms of these components. Within this framework, the most popular schemes include analog readout circuits, mixed signal devices, and all digital versions such as lock-in amplifiers. But these common hardware schemes have some drawbacks in terms of implementation. It is not straightforward to calibrate them. Thinking on wearable devices and portable devices, it is not easy to develop them. So in this work, we present some attractive contributions for accurately measured bioimpedance by means of a synchronous demodulation-like scheme, but using an adaptive algorithm that has minimum uncertainty. The sensor, the biosensor, can be regarded as an algorithmic version instead of classical or classical analog or digital hardware-based devices. And contrary to the most common setups, our sensor works with a single frequency excitation or can accept also frequency sweep modes. So now let's talk about the implementation. First, we will focus in the hardware setup, that is an ad hoc data acquisition system. Here in the block diagram, we can see all the stages involved in the hardware design. The data acquisition system is constructed around an FPGA for signal generation and acquisition. Firstly, a sinusoidal signal voltage is generated through a 14-bit digital analog converter and followed by a low-pass filter to remove high-frequency content. Afterward, the signal is fed into a voltage-controlled current source to convert the voltage in current with a controlled amplitude. And this current drives the high current electrode placed at the biological medium with impedance zeta bio. Therein, the high voltage and low voltage electrodes, that are the inner electrodes, measure the voltage drop via differential amplifier. Also, the impedance is grounded through the low current electrode using a resistor connected to ground. As a result, the output voltage is filtered through an anti-alias low-pass filter and digitized using a 14-bit analog to digital converter. Thereby, the digital versions of the input current and output voltage are stored in a register. Ultimately, the adaptive estimator works around this data to retrieve the real and imaginary components of the measured voltage. Yes, that will be useful to compute the bioimpedance, the complex bioimpedance of the biological medium under test. So the next step and the most interesting part of this talk is about the adaptive estimation algorithm. In the first step, we should define a signal model. First, we can, given the measured voltage with this form, plus additive noise n, we can use simple trigonometric identities and the signal can be interpreted as the sum of orthogonal components, which are called the in-phase component θ1 and the quadrature component θ2. Moreover, after algebraic manipulations, the later expression can be formulated in matrix form as a simple linear regression problem, where we have the regression matrix A and the vector of parameters X, which elements are unknown, θ1 related with the real component of the voltage and θ2 related with the imaginary component of the measured voltage at each time t. So the goal here is to estimate these unknown parameters, which are encoding the in-phase and quadrature components, such that the estimated signal approximates the measured voltage. We need to estimate this signal, and it should be approximately equal to the measured voltage, but decomposed in terms of in-phase and the quadrature components. Next, the second step is the estimator. This is defined as follows. Consider the measured voltage that is low-pass filtered via to provide stability, for the estimator and to clean up some measurement noise. Thus, we have that the filtered signal is Y and is filtered via a positive transfer function in the Laplace domain, H, thus leading to the filtered voltage version. Moreover, the estimation error is defined as the difference between the actual signal and the estimated one. In a system-based approach, the estimator is represented by the following block diagram. So we have here the measured voltage. It is filtered via this transfer function, leading to this cleanup version of the voltage signal, and we define the error as the difference between the measured signal and the estimated one. Next,
5 minutes left, Professor Roberto.
Now we can consider this gain that is related to the time response. So the estimation equation is the derivative of the parameters. So we have here the block diagram. And now we have the estimate derivative. So we need to integrate this derivative, and we perform it by means of a leaky integrator. We appeal to it owing its low computational burden. So after integrating, we retrieve the estimated parameters θ1, θ2, corresponding to the real and imaginary components. Once the estimator converges and recalling the estimated parameters, we can measure online the bioimpedance as the quotient between the parameters and the amplitude of the input current at each time instant. In turn, this leads to the real and imaginary components, which can alternatively be written in terms of the magnitude of phase of this complex bioimpedance. So finally, the results to test our proposal, we carried out experiments on a single dispersion circuit shown here in the left bottom. The RC circuits is mimicking the electrical properties of biological media. Therein, R1 represents the ionic conductivity, whereas the resistor and the other the capacitor and the other resistor are mimicking the dielectric and conductive properties of the sample. So we perform experiments in the range from 1 Hz to 1 MHz. We can see here that the in-phase and quadrature components of the measurement voltage as a function of time, the adaptive estimator retrieved the complex and real voltage component during 5 seconds until the next frequency step. So every 5 seconds, we change the frequency. For the real component, we can see the convergence of the estimator that performs it quite well. On the other hand, the imaginary component is more sensitive to track signal changes, as an overshoot is present, for instance, here. Now, as a second experiment, we perform a change in the capacitance between these values in nanofarads. Here in the plot, we have the magnitude and phase of the bioimpedance. The true values of the capacitance are shown in a dashed line, and the measurements in continuous solid line. So we can see that our estimator is able to track changes in the capacitance every 5 seconds. Interestingly, with these results, one can confirm that the ability of the estimation algorithm to resolve time variant impedance, which is commonly encountered in bioimpedance applications, with finite time conversions and outstanding results. So, as a conclusion, in this work, we introduce a novel algorithm, synchronous demodulation. It is based on an adaptive estimation scheme with accuracy in fast track capabilities. It works in 2 modes, in frequency mode and fixed frequency. It is useful for online bioimpedance measurements and resolve time variant bioimpedance problems. The ongoing work is its implementation in wearable devices, focusing on applications such as real-time impedance tomography, dynamic impedance plethysmography, and biosensors for nucleic acid detection. So thank you for your attention, and again, appreciate the invitation.
Thanks, Professor Roberto, for your participation. We run out of time, so we don't have time for questions, but if someone have a question, we will let you know. Thank you very much.
Thank you.
Let's see. El video de 12, ¿no? Sí. Is the author of the work ID number 12 online?
Yes, sir. I'm online.
Okay, we will put your video, and if there is some question, we will let you know.
Yes, sir.
Okay. Se encuentra en línea el autor. Ponemos el video y si hay preguntas. Ok. Es ¿no?
New benchmarking of online character databases, ¿sí? Y es presentada por
Okay, see, we have time for one question.
Yes.
Okay.
Hey, Kavita.
Yes.
One question is this algorithm can be used for other languages, can be seen as a universal algorithm to do the task?
For other scripts, yes, we can try. If we could try Linet for other task, we could definitely use this model for other task, for other characters.
Thank you.
Yeah. Thank you.
Disculpe, está haciendo mi presentación en track 4 o 5 para pasársela en una WhatsApp.
Ok, está bien. Ok, entonces,
No, no está. Si la tienes,
Sí.
ponemos.
¿Esa por qué no escuchaba?
Sí, estaba grabada, pero es que tenemos problemas con el audio. Es que lo solucionamos. Es que los videos no tenemos manera de que se escuche. Hello, participants from Zoom. Can you hear me? You can write in the chat. Okay. Can you hear me?
Yes.
Okay, thank you very much. We are ready to continue. Okay, ya se corrigió el problema. Please let me know if you can hear the talk. This is live, a live talk. Are you able to see the presentation?
Yes.
Okay, thank you very much. So we can continue wherever you want. Okay, we are ready.
Okay, we will continue with the next topic. This topic is called grouping by mixture of normal corporates, cancer groups, and is presented by Gerardo.
Very good morning to questions. We are presenting grouping by mixture of normal for breast cancer in two groups, benign and malignant. The authors are Martín Guzmán, María Beatriz Bernal Llorando, Rubén Martínez Mancilla, Carmen Salón Basic application. Next one, please. Introduction, data management, basis, results, and conclusions. Breast cancer is positioned as the second cancer in number of types of cancer. Only a decade earlier, more than 100,000 cases detected and 14,000 deaths in the breast cancer. This is resulting in an increase of 38.29% in cases, or only 1.95% deaths. What does this mean? Okay. The fact that recent years in effort has been to detect breast cancer on time. Okay, there is a better prognosis in cancer if we detect the cancer on time and it has no metastasis. When breast cancer is metastasis, a main metastasis, the probability of the death increases a lot. The next one, please. And this occurs not only in United States or in Mexico, it's the first cause of death in what is all about cancers. Okay, it's important to take the size in the dose because directly impacts the cell migration. Different nuclear proteins play an important role in differentiation and to cells replicate and control or regulation in the nucleus and the cancer structure. Okay, these changes impact on metastasis. Okay, the nuclear proteins and its mesh, for example, and most important, the protein results in a decrease on the size of the nucleus. On the size of the nucleus can be small, in cancer can be small, large, can be grow, and will lead regularly to the regulation and therefore the cancer. Machine learning and techniques. Okay. We are using machine learning, unsupervised learning, and supervised learning. In supervised learning, we use classification and regression, and in supervised, the most difficult, we are using clustering. Okay, this technique allows extraction of patterns and be able for predictions. Okay, that are uncertain. Remember, divided into supervised learning and unsupervised learning. We in supervised learning we are using the label, okay, and we are based on denominator characteristics. And we are training these labels and to know the full field of learning. Here on unsupervised learning, we the most difficult, we must be extract the patterns to obtain the relevant information. We are not using the defined labels that are using here, and it's more difficult to know information. And we are priority parties for being we are searching for. Okay. And supervised learning we use these two: classification problems and regulation problems. Classification problems characterize what the categorical output data, and both classified binary and multi-class. Okay. And regression problems that differs from a continuous variable, and there's a linear regression. And then we are prediction using a linear norm function, and a linear regression that can be, for example, quadratic polynomial function. The next one, please. Unsupervised learning. We are focusing differentiating from the supervised learning on the clustering. The clustering problems, which are the data who are not labeled, but and they take the input data from diverse sets. The number of clusters can be defined by the user. This technique save automatically the number of clusters. These models, for example, he means based in centroids. The method used in this work is expectation maximization, EA. Okay, the distribution of the measures can be employed from different models heterogeneous and in mixing combinations defined by each parameters and components. The EM algorithm expectation maximization is an iterative usual tool of the estimation of the maximum likelihood of the mixed distribution. Okay. The next one, please. Okay. What is the objective? From the probability distribution to be known of the two normal distributions, there is an estimation of an unknown parameter through the statistical method of supervised learning called expectation and maximization. This obtains two clusters totally specified. Subsequently, we calculate the standard error by using bootstrap technique. Our data analysis case of study. Okay. Okay. What's the case of study? The data available was a sample of 569 women, each one identified with ID, and the diagnosis of tumor, benign or malignant. The value of the radius, the variable, the principal variable. Using this variable, we are taking account of 169 total observations. 357 observations indicate absence of cancer cells. Meanwhile, 212 observations shows presence of cancer cells. The histogram, a frequency variable in the diagnostic accuracy per here. The ones who are here are benign, and the ones who here are malignant. Okay. Please. The analysis of this work. The analysis of this work has an objective to determine the extent of the rate that is useful to predict if the tumor is benignant or malignant. A model of this developed and value radius variable established that can contribute achievement that this model can contribute to the diagnosis of the tumors. This is benignant or malignant. We use two Gaussian components, and also we assume that the first one is small, and the second one. Okay. These algorithms start taking account in the initial values, and the initial values for other parameters are calculated from data, from the base data we have.
Sorry, I have a question. What is the meaning of new? What is the meaning of new?
Of new?
New?
Please let me finish and let me explain because it's very good. Okay. When this data algorithm starts to calculate approximately the data of maximum. The algorithm stops in the iteration when it's satisfied. Okay. The next one. Okay. Which can yield this result. The next one. And our results. Okay. We obtain the standard error of the parameters, the bootstrap technique. With the bootstrap technique, sorry. Continue, please. Bootstrap method introduced by Bradley Erford. It's a method of Monte Carlo parameter and intended to estimate population characteristics by through sampling. This method sampled an observed sample as of in this case, the finite population of breast cancer and generate random samples of single population. There is they are alternative and complex techniques of computational statistical analysis by intensive calculus about generated samples. The next one, please. These steps standard error for the initial sample. X1, X2, Xn. These samples, independent samples, are generated. Okay. The standard error is estimated by standard deviation of the repetitions. Next one. Using the bootstrap algorithm for 1,000 samples, the standard error of each one of the parameters are obtained and show. Okay. The next one is, and our conclusions for our report. From 569 observations, we observed 62.7 indicate the absence of cancer cells. Meanwhile, 37.3% shows the presence of cancer cells. With the model of mixed normals, we found that 73.8% indicated absence of cancer cells, while 26.2% shows the presence of cancer cells. In the case of benign tumors, the coincidence is 97.8% of benign cases, with a difference of only 8 cases. Meanwhile, the cases finding that there is a coincidence of 66.5 malignant cases, with a difference of 71 cases. Okay. The model of, in this case, of benign tumors has very good, with a good acceptance of prediction. In the cases of malignant tumors, the prediction is not very good. In the last case, it should take into account in the study of Dr. Wolbeck and indicate the percentage initially large. The data conjunction does not represent indicate statistical distribution of medical data. In general, there will be a considerable amount of cases that represent negative versus small of cases that represent positive tumors in the case of malignant tumors. This measure can correlate the difference that was found in the malignant cases. Okay. This model that we have applied can be not only applied in what is breast cancer, can be applied in different modes of cancer, for example, lung cancer or sarcomas. There are actually in the world, lung cancer is starting the deadliest cancer around the world. Not in Mexico, but breast cancer is the deadliest cancer here in Mexico, and almost can be used in uterine cancer. Okay, this algorithm, this model can reduce the variable range, but we can use more variables to be more specific about the difference between benign and malignant tumors. Okay. Next one, please. These are references. That's the next one. And this one is the database. The breast cancer becomes it. If you have any question, you can check that. Next one. And this is my email. If you have any question, and thank you very much for listening.
Okay, we have a question.
Which are the model that can
Tres.
Okay, the model we are.
Ok. Y si le decimos que presente.
For example,
Y si le decimos que presente.
es que ahorita tomamos el radio.
Ok, profesor Vladimir Batkin, are you online?
¿Qué tipo de células han invadido la membrana basal?
Can you present your talk?
¿Cuáles son más probables a que sean tumores malignos o tumores benignos?
Give me a second.
También,
We are in a question here on live.
Muchas veces utilizamos lo que es la glucosa para determinar el consumo de una célula y el metabolismo de una célula para ver normalmente que las células cancerígenas consumen más glucosa. Entonces, podemos determinar la cantidad de glucosa que una célula, a diferencia de una célula normal, consume. De esta manera determinar y diferenciar entre lo que es una célula maligna y una célula benigna. Esto se aplica no solamente en las células de cáncer de mama, que son las más comunes en lo que es el cáncer de mama. Nosotros son las más típico el cáncer de mama en nuestro país. Se puede aplicar también principalmente a lo que es el cáncer de pulmón, debido a que con el pulmón, aunque no se ve mucho, que también influye en muchos procesos del metabolismo, también es afectado y puede ser utilizado de la misma manera. ¿Sí me entiende? ¿O no entendió la pregunta?
Es que utilizas Machine Learning y utilizas Monte Carlo, entonces a partir de ahí obtienes parámetros relacionados con las ecuaciones que mostraste y esos parámetros era lo que te preguntaba para identificar cómo es que haces esa distinción.
Okay. I'm sorry, but our time is finished. So please, if you have more questions, you can talk.
Okay, the next talk is Professor Vladimir Batkin, experimental study of high frequency drill string vibrations under different conditions. He's online. He's going to present his talk online. So let me give you again, the control of the video. Okay, we can hear you and we can see you. You are.
Yes, I sent my recording to you.
Okay.
So could you please start?
Yes, I will start it.
Thank you.
Vladimir, can you hear me?
I think that he only can.
There is no sound, unfortunately. So what can I do? Could you please give me a right to demonstrate my screen? I can't demonstrate my screen because of permission. Надо как-то по-другому, потому что как? Hello, dear colleagues. Hello, dear colleagues. My name is Vladimir Bakhtin from the Institute of Applied Physics of the Russian Academy of Sciences, Russia, and I'm glad to present you our work, experimental study of high-frequency drill string vibrations under different conditions. The outline of our work is presented at this slide. Firstly, I would like to say some words about our motivation. Drilling facility and environment are undergone to significant vibration loads in the process of drilling. It is necessary to take into account those vibrations when designing drilling equipment, since they determine the failure of the equipment. Those vibrations can also have negative influence on the inner surface of a borehole. Information about the vibration level is also important for borehole acoustic communication system designing. The spectrum and the noise level determine the maximum data transfer rate and the frequency range available. Vibrations caused by drilling equipment operation can be used for estimating surrounding rock characteristic and characterize the drilling facility operation itself. Thus, the investigation of drill string vibration is highly actual problem. The overwhelming number of investigation of vibrations during drilling is devoted to the lower frequency part of a vibration spectrum below 500 Hz. Practically, the higher frequency spectrum part has not been investigated, although it obviously contains a significant amount of information about the physical processes taking place during drilling. The purpose of this paper is presenting the preliminary results are related to measurements of high frequency drill string vibrations. Well, just a moment. Well, now let's turn to borehole noise recorder. The autonomous borehole noise recorder, the BNR, is a special device which is designed for measuring higher frequency components of drill string vibrations. Figure 1 shows the appearance of the BNR case. The BNR case is a cylinder with a diameter of 127 millimeters and a length of 738 millimeters with an internal non-central hole for pumping drilling mud. The BNR is equipped with standard conical thrust thread for installation into any part of vibration of drilling string. The vibration are measured by means of 3 accelerometers. The measuring axis of those accelerometers form an orthogonal coordinate system. The accelerometers are miniature and have a natural resonance frequency of about 90 kilohertz. The electrical signal from those accelerometers is amplified by a charge amplifier with a tunable transmission coefficient, which is automatically adjusted the current input signal level. The charge amplifier cutoff frequency is 500 Hz. Just a moment. The key features of the BNR are, firstly, it is vibration and temperature proof. Secondly, it can autonomously operate for 300 hours. Thirdly, it can be mounted into any part of drilling string. Fourthly, it can measure all 3 vibration components. Figure 2 shows photos of the BNR case before and after drilling trip. We can, as we can see, there are deep scratches in the surface of the BNR case. So conditions in the borehole could be really rough. Now let's turn to measurement conditions. So I would like to pay some attention to some important measurement conditions. Firstly, the borehole noise recorder is built in the lower part of the drilling string near to a mud motor. Secondly, a PDC bit is mounted at the end of drilling string. Thirdly, measurements are carried out under following drilling operations. For example, rotary drilling, directional drilling, reaming, making a connection, and circulation. And fourthly, measurements are performed either through horizontal and vertical drilling, and takes several days. So now, let me show you measurement results. At first, look at temperature and pressure change protocol. Temperature measurement protocol is shown in figure 3. Type of drilling operation is encoded by a color. For example, red lines represents a fragment of rotary drilling. Green lines fragment of directional drilling. Blue lines fragment of making a connection. Magenta lines a fragment of reaming, and cyan lines a fragment of circulation. Pressure measurement protocol is shown in figure 4. Type of drilling operation is also encoded by the same colors. Pressure and temperature time dependence has a periodic nature and might be caused by some harmonic processes. Well, figure 5 shows the acceleration signal for 3 time scales, illustrating changeableness of drill string lower part vibrations. When the time scale has an order of hours, upper graph figure 5, there is a stationarity in acceleration signal. Quasi-periodic repeating variations of amplitude are observed. The reason for this is that the same operation are interchanging one another in the process of drilling. Generally, it could be described as a cycle: rock breaking, remained drill cuttings removal. If the time scale has an order of minutes, figure 5 middle graph, it is impossible to say about any stationarity. However, the average vibration level is changing smoothly at this time scale. This effect is probably connected with equipment inertness while switching between operation modes. At smallest time scale, lower graph figure 5, the acceleration signal has a form of radio impulse superposition. In all probability, each of those impulses appears due to impact interaction between drilling string and borehole borders. Since a rock is inhomogeneous and borehole borders are rough, moments of interactions should be random. Figure 6 shows vibration spectral power density of drilling string bottom part. Graphs A and C correspond to the vertical borehole, crosswise and along directions, and B and D corresponds to a horizontal borehole, also crosswise and along directions. Type of drilling operation is encoded by a line color. Figure 6 shows that A, vibration level during vertical drilling is lower than during horizontal drilling. B, vibration character is similar in along and across in crosswise direction. C, frequency spectra obtained for vibration along borehole include more discrete components. So now let's turn to conclusion. And to sum up, I would like to repeat the main points of our article. High frequency drilling string vibration, high frequency drilling string vibration measurements were carried out during different drilling operations. During intense operations, vibration have an appearance of harmonic oscillation superposition at frequencies below 200 Hertz. Finally, the vibration character is similar in along and crosswise direction, but the vibration level during vertical drilling is lower than during horizontal drilling. Thank you for your attention, and I will be glad to answer your questions. Thank you.
Сейчас надо реагировать, можно в чате вопросы, он там чат проверит.
Are there any questions?
Что не стало.
Все. Все?
Any question?
Yes, of course.
I'm sorry, I'm asking if there is any question around here. No questions? Looks like no. Thank you very much for your talk, Vladimir.
Thank you for your attention.
Now, please, Marco Antonio Esperon Pintos, please, to avoid these problems of video, could you share your screen with the talk flexible systolic hardware architecture for computing a custom lightweight CNN and CT images processing for automated COVID diagnosis? Please, work ID 4, would you share your talk? Okay, we are waiting for share the presentation. of the next talker. He is face to face. So please wait just a minute.
Yeah. This can give us, well, this can give us like a reference of what is the quantity of production of proteins, and it can give us to the how fast it generates these proteins in the cell. So transcription factors are responsible for reading genes into RNA, which are then translated into proteins that can interact with the environment. And then it is concluded that gene expression is a process by which genotype information gives rise to the phenotype. It means observable characteristic. Next one. So here we have these stochastic processes. So we can see that these are time series. And time series are a concentration of transcription factors versus the time.
So how we can see the stochastic process? Well, we can imagine like a sample of glass water, and this sample, well, we can put a particle in the middle of the glass, and we can see that this particle is moved in different position in the when we do this experiment in different glasses. So it won't happen in the glasses. The trajectory is not the same in the glasses. It changes, and this changes because it's a stochastic process. So it is not deterministic. So we can see that these processes are not deterministic. So this sample changes when we have different realizations. And in this image, we have the time series of E coupling, and this is obtained from Novak et al. The next one, please. So in this work, the time series are generated synthetically with help of Python. What is the main characteristic of this time series is that they have a fractality. The fractality means that these time series are invariant are autosimilar or invariant in the scale. The next one, please. So one of a parameter that has this time series is the Hertz exponent that is highly related with the fractal dimension. And these parameters tell us like a characteristic of the persistation or correlation that has this kind of time series. So when this parameter takes a value between 0 and 0.5, it corresponds to an anti-persistent or anti-correlation behavior in the time series. It means that a period of growth is followed by a period of decrease, and which is characterized by a higher high frequency content. Then when this parameter takes value between 0.5 and 1, this time series showing persistent or correlated processes. It means that one period of growth it is followed by another one and present a smooth appearance. And then when this parameter take value 0.5, it means that it's completely random and an independent process. So this means like that is Brownian motion with no correlation between signal increments. The next one, please. So here we can see some time series, time fractal series generated with Python, and this fractal series express different Hertz exponents. So we can see what is happening when we have a Hertz exponent lower than 0.5, and it's really noisy, the signal. So when we increment this exponent, we can see that there is a little bit correlation between the signals. So when we have this, when the signal is decreasing, it's probably that we can see another period of decrease with the signal. So we can see that when the Hertz exponent is higher than 0.5, the time series is really persistent and it's more or less like a deterministic signal. The next one, please. Okay, so the second objective of this work was to train some neural networks with these signals and with the instinct that were the Hertz exponent. So what was the result? Well, if we can see these graphics, we have the loss, the cost function between versus the epochs, the number of epochs, and we can see with a dense neural network. And then in the second images, the right, we can see the Hot exponent in this axis, the y-axis, versus the Hot exponent, but predicted with the dense neural network. Next one, please. So we can see the same thing, but now using an LSTM neural network, the expansion versus the epoch, and then the Hot exponent in the y-axis versus the Hot exponent predicted by the neural network. So we expected to see that the line with slope 45 degrees more or less, and it would be the expected result. And in these images, we can see that we have a better result compared with the dense neural network. Next one, please. Now we have a convolutional neural network, and we can see that the results are better than the last, the next one. So far, we have a complete record of 3 neural networks using machine learning and manipulating the data time series that are within the time and frequency domain. Well, in the graphs that I show you in the place, the analytical place is just with the time domain. But in this work, we do we transform the time series in the frequency domain to see if have a better result. The second conclusion is that the dense neural network, the second characteristic is that the dense neural network and LSTM were used to have 8 neurons in the input layer, 8 neurons in the intermediate layer, and 1 neuron in the output layer. And for the convolutional neural network, 4 unidimensional filters or windows of 10 inputs, which are subsequently linked to a dense network of 8 neurons in the intermediate layer and 1 neuron in the output layer. And well, the cost function used was the mean absolute error, and the results obtained are shown in the following table. Well, we have these the 2 dense with 100 epochs, and the time series domain. The first one is in temporal domain, and the second one is in frequency. We can see that the test, when we see the absolute error, is better in the frequency domain when we use this. And then when we use LSTM, the number of epochs are 20, and it's better when we use it with the frequency domain. And then we use the convolutional neural networks with 15 epochs, and then with 200 epochs. And we can see that in the temporal domain, with 15 epochs is better. Well, thank you.
Do we have questions online?
So at the end of the day, you only perform a calibration with your data. So what was the idea to use this fractal idea?
Okay. Yeah, the main idea is that this time series, based in some articles of expression, when we represent this time series in the this this time series, when we represent it, based in this article, the Hertz exponent, when it is bigger than 0.5, the cell represent a healthy state, a healthy state. So when it's less than 0.5, the cell is not healthy. So we can characterize this time series with this.
A ver, ahorita veo si está Paulo en línea. Is there Paulo online?
This is like a process to determine if the cell is healthy or not.
No hay question. There is no questions online.
Which training method you use for train your evolutional neural network? What was your method?
Okay, so when you train a neural network, you use a kernel, so it's a filter. And so when you put the inputs of the neural network, it's like a vector, and all the inputs in the array of the vector is the point of the time series. So okay, you put in that vector in that array all the points in the time series, and then you label it with the Hurley exponent. Okay, so when you use a evolutional neural network, you use a kernel, so it's a filter, and this filter produces some. Yes, it's like a product of all of a window. You take some window of that vector, and you make a product. So you reduce this number, and then you put it in a dense neural network. Yes, that's more or less the process.
Okay, so thank you very much. And this one is saying that there is a break, so okay, it's time for a coffee.
Okay.
So we are going to have a quick break of 10 minutes. After that, we have the presentation.
Ya me está ayudando la doctora
The
Claudia
presentation of Redwanul Islam with the ID 7. Please be prepared with your video or with your slides to present online.
Y el 7 no sé. Pero ya se les avisó a todos. Ajá. Se les avisó a los participantes en línea que mejor presenten en línea. Es más fácil. Porque es que los videos no se escuchan. No, o sea, se escuchan aquí, sí, pero no se alcanzan a oír en Zoom. Se escucha bien bajito. Entonces es mejor que lo vean en línea.
Yo creo que puede ser mejor eso.
Ok.
¿Tienes más entradas?
No, ya no. Son todas.
Sí, para que
Yair, cierra tu micro.
Sí, gracias. Ahorita lo cierro.
Yo sí no sé si estaban batallando con esos para.
Entonces, ahorita yo creo que
Aquí ya con este.
Hello, is around here Radwanul Islam?
Yes, I am present.
Okay, thank you. So you're going after work ID 4, Paularon Aguirre Alvarez. He is going to present a face-to-face. So just a couple minutes, we're going to start. Thank you. After that, we have the presentation of work ID 8, Majesha Binta.
Yes, I am present.
Thank you very much. And work ID 1100, Saurabh Malik. Is Saurabh Malik around here? Okay, we'll wait then. Thank you very much. So we are ready to start. Thank you.
Sí.
Okay. We are ready to start the next talk.
Okay, so we will continue with the next talk. This is presented by Pablo Aron Aguirre Alvarez. Hardware architecture for CNN in CD images processing for automated COVID-19 analysis.
Thank you for joining us today. Well, next let's start introduction and followed by a description about each contribution. And then I will present our obtained results, and finally I will give a brief conclusion. So thank you very much. You can hear me? Okay, you can hear me? Okay. Well, in this work, we propose a hardware architecture which is capable of sequentially processing each layer of an convolutional neural network. However, its outstanding feature is the capability to adapting to different configuration of convolutional layers. And then, as a case study, we propose applying this architecture in the detection of COVID-19 in images of computerized tomographies. Okay, and the next one, please. And the next. Okay, we use we propose a convolutional neural network which have a low number of convolutional layers, and which is capable of classifying images from the SARS-CoV-2 CT scan dataset. Okay, and now in this slide we can see the composition of this dataset. Next, please. We propose preprocessing the images in order to diminish the necessary complexity of our network. Then we multiply a resized image by a mask in order to remove the unnecessary information in the background. Then this is our CNN proposal. Only have 2 convolutional layers and only implies this amount of learnable parameters. And The next, please. Now, our main concern is our proposal of a hardware architecture. Okay. Then now I'm going to explain this system as a block diagram. The next, please. Well, here, before the processing of convolutional layer, each module is configured according to the configuration of the present layer. Well, then, next, please. The input image enters to the input RAM, and then, next, please. All of convolutional mask is generated by a module named programmable line buffer (PLB). Then each window is sent to the flexible convolver. Okay, the next, please. This is composed by a systolic array and data buffers with programmable length. Then, next, please. Up to 9 partial output pixels are generated, and then this result is updated with the bias model, adding this term to the results. The next, please. And then these results are organized and stored in a memory named CNV rank block. The next, please. Now, during a max Boolean layer processing, now up to 3 input channels are processed by the ReLU layer, and real model, sorry, and also 3 masks of 2 by 2 pixels are generated and processed by the max Boolean model, and then the results are stored in MXP RAM block. The following next. During the processing of a second convolutional layer, then the input data comes from MXP RAM block. Then the same process is repeated. And finally, during the processing of a fully connected layer, some processing elements of the systolic array are reused in order to give the results, which are compared in this classifier model, and the class of which the image belongs is determined. More in detail, our proposal consists on this block named programmable line buffer. Then each input pixels enters to this chain of 3 registers, and then in the dotted boxes, a window is generated. However, we propose at different extra data paths and multiplexers in order to vary the size of this window. And then also we propose some C registers with programmable length, which consists on C registers with a length of power of 2 interconnected by multiplexers. These elements contains the rest of the input image row. And the next, please. Now, we take a systolic array as a base of our design. Here, each processing element P calculates an output partial pixel, and the number of rows and columns of this array represents the number of windows and filters processed in parallel. However, our addition in this system is different buffers, which behaves as a chip register with variable length. Okay, again, the idea is use a chip register of different lengths interconnected by multiplexers. Okay, the way buffers reuse the use buffers, reuse weights in order to diminish the number of memory accesses. And in the other hand, the mask buffers captures in parallel the produced mask. Well, as a result, we can see our training setup. We divide our data set in percentage of 70, 20, and 10 for train, validation, and test respectively. Then we train our network using this configuration, and we quantify the number of of true negative, true positive, false positive, and false negative predictions. And we calculate or accuracy, precision, recall, and F1 score. In comparison with other works, we obtain a higher accuracy with less convolutional layers. The importance in this aspect is that convolutional layer is a heavy operation in terms of hardware. So while they have less convolutional layers represent a processing more fast. Well, respecting to the VHDL description, we use simulation in model scene and taking as reference this device Cyclone 5. The next, please. Then we can see our results during the processing of each layer. As you can see, we presented our processing time. We obtain 23 frames per second. This means an instantaneous results. And there's also the complexity represents the number of operations performed in the layer, and also the throughput is the speed with this operation are performed. Next, please. So in comparison with other works, we obtain a higher throughput with less multiplier units, which is a hardware scarce resource. And also, we obtain a better proposal of hardware than the proposed by Gani, because his architecture is limited to only process 2 filters. It's very impractical in a real scenario. Okay, and respecting with wood, we can observe that this proposal achieves a higher performance, but as well as the other works, only supports 1 filter size, okay? And supporting different sizes of filters is very useful because you can design your custom CNN knowing that this architecture can support it. You don't need the script in the HDL or the new architecture. Excellent. Well, as a conclusion, we can see that an implementation of a lightweight CNN in a low-end hardware for the classification of city images represents an instantaneous and accurate method to diagnose the COVID-19. Also, our proposal hardware, which is the most important here, achieves a great adaptability to different configurations and also allows exploring different configuration of convolutional layers to achieve a better feature extraction during the design of your network. And that is all for my part. Thank you very much. And you have any question?
Any questions?
Do we have questions online?
Yes, okay. Well, I have a question. What's the rationale to use the it's just because there's the mainstream of researchers going in that direction and you use it for that, or think take something else. Why to use convolutional?
Okay, way to use convolutional neural network. Well, currently, the CNN achieves and is demonstrated achieves a higher results in terms of accuracy and the other aspect that I presented in comparison with other machine learning techniques. Also, achieves a better recognition capability in comparison with the capabilities of the human. Well, this is the reason because the CNNs are very useful in this aspect and are applicable in different scenarios.
But for instance, you have influenza or some other lung disease, or it's capable to distinguish between copy and
okay. In this case, only exists one paper related with implementation in hardware of a CNN. And also currently exists other studies about the the usage of popular networks such as BG16 or AlexNet, etc. Well, the difference between these works and our proposal is that we prefer to use a live CNN because it's more suitable in a scarce resource hardware. Okay.
You say your work is better. It means it's faster because you use only 2 or 3, I do not remember.
2 trillion frames per second. See.
So as a result, of course, your work is faster. But what's the difference? In this case, you need only to know if the patient has or not. Who matters to wait 1 millisecond for 1 second?
Okay, this is a very interesting question. Okay, as I mentioned, this architecture is able to process whichever configuration of convolutional layer, which is composed by convolutional, max pooling, review, and fully connected layers. So you can apply the same architecture to different applications, not only the recognition of COVID-19. And this is very variable in the sense that the description of a hardware architecture is very, you need many time to describe this in an FPGA. And if you have a chip that can achieve this task, it's very useful. For example, in the case of the tomography machines, you can apply different deep learning, different CNNs for different kinds of recognition. For example, in different parts of your body, etc. So, in this aspect, regards the value of this work.
Okay. So it will be better for you to use this hardware, for example, in automated driving vehicles or things like that.
Yes.
In that situation, it's important to have 23, for example, FPS to process or to decide. But in this case,
okay. Yes. Yes.
There is any other question in line? There is another question?
No, there are no questions online.
Okay, so thank you very much, Paulo, for your talking. The next talk is called is presented by Redwanul Islam.
Redwanul Islam is around here, please.
Yes, I am here.
Please share your screen or your video as you desire.
And then SPM mode. Please, Redwanul.
Greetings everyone. I am Redwanul Islam, Department of Biomedical Engineering, Khulna University of Engineering and Technology, Bangladesh. My paper ID is 07. My paper title is Epileptic Seizure Detection from EEG Signal using ANN LSTM model. These are the outlines of my presentation. Introduction. Epilepsy is a neurological disorder. It affects at least 50 million people globally, with 2.4 million people diagnosed with epilepsy each year. Seizures are the most common symptom of epilepsy and characterized as a transient change in movement, behavior, sensation, at least from a few seconds to a few minutes. A seizure occurs when the human brain begins to produce 4 times larger signal than the typical brain signal. As a result, EEG is a crucial test for diagnosing epilepsy. Epilepsy has a significant physiological and social impact, and the unpredictable nature of epilepsy period can make it a life-threatening condition. As a result, seizure prediction will improve the quality of life of epilepsy patient in a variety of ways, including providing an early warning before a seizure starts. The focus of this paper is to propose a deep learning-based system that integrates the ANN and LSTM networks to identify epileptic seizures automatically. Related works. Researchers around the world utilizing different methods for detection of epilepsy. J. Lesfer are proposed to apply a new approach to detect epileptic signal by discrete wavelet transform for feature extraction and threshold processing to eliminate noisy parts. They achieved 98.1% accuracy. M. Funny et al. Used to frequency and energies of different subband EEG signal for the extraction of feature from the data. The features were applied to ANN network and got 94% accuracy. M. Youssef et al. Proposed a method to detect epileptic during seizure-free period. They used to maximum, minimum, STD, entropy, range, and energy as their feature and applied to SBM method. They found 99% accuracy. Methodology: data collection and description. Well-known and publicly available epilepsy dataset from Bonn University, Germany was used in this work. There are five folders in this collection, each with 100 files representing one subject. Each file in the collection is the 23.6 second recording of the brain activity. The EEG data was sampled at 173 Hz and run through a 40 Hz low-pass filter. Data processing. Time series data corresponding to EEG is sampled at 4097 data points. Each data point represents a distinct EEG record value at a different time. There are 500 subjects in total, each with 4097 data points collected in 23.5 seconds, with 174 data points per second. The figure 1 represents the visualization of some sample signal. Proposed ANN and ANN LSTM model. In this work, we built a hybrid model. The structure of this architecture is created by integrating the ANN and LSTM network, where the ANN extracts important functionality from the input and LSTM acts as a classifier. The table 2 shows the proposed integrated epilepsy detection network. The network consists of 2 convolutional layers, 2 pooling layers, 3 dropout layers, 2 LSTM layers, 2 dense layers, as 1 fully connected layer and an output layer with sigmoid function. Hyperparameter optimization. The ADOM optimizer was used with learning across 128 and epoch 50. Assessment matrix. Accuracy, precision, sensitivity, specificity, and F1 score were used to evaluate the model. Experimental setup. The data set was divided into 80% for training and 20% for testing in the experiment. The 5-fold cross-validation procedure was used to achieve the findings. Python, Keras, TensorFlow environment was used to implement the model. Result and discussion. The data was applied to ANN LSTM and combined ANN LSTM model. The figure 2 shows the accuracy of ANN LSTM and ANN LSTM model. The ANN LSTM model shows the best accuracy among them. Confusion matrix. Figure 3 shows the confusion matrix for ANN LSTM and ANN LSTM model. The ANN and LSTM architecture misclassified 141 and 194 of the 3680 instance respectively. On the other hand, ANN LSTM architecture misclassified just 20 instances. Performance evaluation. The value of precision, sensitivity, specificity, and F1 score indicate the model performance. ANN LSTM model shows the highest value for this standard matrix. Furthermore, throughout the training and validation phase, figure 4 visually describes the progress of ANN LSTM classifier in terms of accuracy and loss. At epoch 50, the training and validation accuracy are 99.7 and 99.5%. Similarly, ANN LSTM models training and validation loss are 0.0038 and 0.0072 respectively. Figure 4 shows the comparison between our work and some other related work, and we see that from the table 4 that our model performs better than previously reported work. Conclusion: the ANN LSTM model is used in this work to identify and characterize epileptic seizures step using EEG data. The trained network had a classification accuracy of 99.46%. Further study in this field will evaluate the suggested model competency using various epileptic seizure datasets. We will also turn our research into a hardware device that alerts epileptic patient to imminent seizure and allows them to avoid potentially risky situation in the future. These are some reference of our work. Thanks all. Hello. Hello.
Hello.
Questions online?
Can you hear me?
Yes.
Any question?
We have one question.
Hi, Professor Redwanul. A question like, suppose that the device works and then what the subject needs to do after that? That's one question. Well, I'll have another second one, but just
to build a device is our future work. In here we train our model the well-known data set that is available on the net. In future, we try to build a device that can measure EEG from real time, and use this model we can detect epilepsy.
But then the patient supposed to take medicine or
there is also treatment for the epilepsy, but detect epilepsy very fast. We try this model to detect epilepsy very fast.
Okay, I see. And the other, it's not clear to me, but if this dynamic detection that it follows the signal in time and real time and can predict when the onset of epilepsy might happen. Because for me, it seems like you are having a situation before and then when the crisis already start. But in between, there's a way that your algorithm can tell you when there's the onset of epilepsy activity.
Epilepsy signal, mainly when the epilepsy occurs, the range of the signal is faster than normal. So when we implement a device, the device detect the range of epilepsy. When it follows the range of normal, then the device show it is normal. But when the range of the signal is beyond the normal range, then it shows that the epilepsy occurs.
Oh, okay. See. Thank you.
Thank you.
Another question from people online. There is another question.
There are no questions online.
Okay, so if that's the case, thank you very much for your talking.
So thank you very much for your talking, Redwanul Islam. So now, please, Rashid, Mayesha, could you please share your screen? And also, you are going to record your video or speak?
Okay, I'll start my video now.
Okay, as you wish, but just a little thing. Could you increase your volume in order that people around here could you hear your talk better? Just increase your volume a little bit. Thank you.
Okay.
Okay, so
Hello everyone, I would like first of all to thank the organizer of this conference for inviting me here today to present my research paper in diversity reduction in handwritten digit recognition. Let me introduce myself. I am Maisha Binti Mizar from the Bangladesh University of Professionals in Dhaka, Bangladesh. Sometimes there are many features in machine. Can you show my screen?
Now, yes.
We can see now the screen.
Okay. Sorry. Hello everyone, I would like first of all to thank the organizer of this conference for inviting me here today to present my research paper in diversity reduction in handwritten digit recognition. Let me introduce myself. I am Maisha Binti Mizar from the Bangladesh University of Professionals in Dhaka, Bangladesh. Sometimes there are many features in machine learning classification problems and that's why it is difficult to work with. The higher the number of features, the harder it gets to visualize the training set and then work on it. This is why dimensionality reduction algorithms comes to play. Dimensionality reduction is the process of reducing the number of input features, variables, or columns present in a given dataset. Bangla being the seventh most spoken native language in the world, the amount of research done on Bangla handwritten digit recognition is comparatively less than English, which is the reason we decided to work on it. Our goal is to experiment with dimensionality reduction algorithms and CNN on Bangla handwritten digit dataset to observe how the dimensionality reduction algorithms perform compared to one another. In 2005, Bhattacharya et al. Did the first research on Bangla digit recognition with their self-constructed data set using multi-layer perceptor. In 2008, Zhou et al. Used a hierarchical balancing network with their self-constructed dataset which contains only 2000 images and got an average accuracy. In 2013, Sunitra et al. Experiment using SVM with a self-constructed dataset and got 96.8% accuracy. Akand et al. Did research twice in 2015 and 2016. In 2015, they used CNN with their own dataset and after a year, they used 3 different models of CNN with ISI dataset. Both of experiment, they got good results. In the recent times, we can see that Rahman et al. Used a CNN architecture with 3 different types of dataset, ISI, CMATER DB and NumPy DB, and they got really good accuracy. But day by day, the now image quality is getting better, so the pixel experience is getting complicated. NLP is better than CNN with complicated inputs. On the other hand, SVM and Martian networks did not perform well with a large amount of data. So here we can see that the researchers shift their focus on CNN with other algorithms for image classifications. Key concepts. Diversity reduction is a method of reducing the number of features in our dataset. Here we have used some diversity reduction algorithms such as principal component analysis, linear discriminant analysis, and neighborhood component analysis. So PCM is the most widely used dimensionality reduction technique. PCI applied to the data identifies the combination of principal components or direction in the feature space that accounts for the most variance in the data. LDM. LDM is a dimensionality reduction technique used to find a linear combination of features separating 2 or more data classes. The aim of LDM is to maximize the between class variance and minimize the within class variance through a linear discriminant function. NCM tries to find a feature space that is a stochastic nearest neighborhood algorithm will give the best accuracy. It is generally used in regression and classification problems as we work with images, so our work addresses as a classification problem and we get the best result by implementing NCM. CNN, convolutional neural network, is a type of artificial neural network used in image recognition and processing, especially designed to process pixel data. There are 3 layers in CNN architecture: convolutional layer, pooling layer, and fully connected layer. The convolutional layer is the core building block of a CNN. It requires a few components which are the input data, filter, and feature map. This does mainly feature extraction. Pooling layer basically reduces the parameters in the input. There are two types of pooling: max pooling and average pooling. In the fully connected layer, each node in the output layer connects directly to the nodes in the previous layer. Here we use Jupyter Notebook as our code editor. To do our research, we use various libraries such as NumPy, OpenCV, Pandas, Matplotlib for data preprocessing and plotting results. TensorFlow and Keras are used implementing CNN and generate confusion matrix. Sklearn was used to implement PCA, NCA, LDA algorithms for ambiguity reduction. Here are the dataset. NumDB equal Banglalekha isolated with the number of images. All the datasets are available in Kaggle. Methodology. For data preprocessing, at first we downloaded the NumDB dataset from Kaggle and then used OpenCV to read the images and convert the RGB color images to grayscale images. The pixel values of images can range from 0 to 255. If we pass the image through a neural network, the compilation of high numeric values become more complex. To reduce this, we normalize the value from 0 to 1. Then the dataset was split into train and test subsets. 80% was used for training and 20% for testing. Then we applied density reduction algorithms on our data using a Sklearn library. Here we can see the raw images of NumDB dataset and the grayscale images. For CNN, we use LNet 5 architecture, which has 7 layers. Here C represents the convolution layer, S represents subsampling, and F represents fully connected layer. The network accepted a 32 by 32 by 1 image tensor as input after the first convolution layer, and first pooling layer it becomes 14 by 14 by 6. Then it is then again after the second convolution layer and pooling layer it becomes 5 by 5 by 16. Then it is cluttered, and after the first and second fully connected layer it becomes 84 by 1. After the third and last fully connected layer it becomes 10 by 1, and last pass through a softmax activation function which contains the predictions of the network. Result analysis. Then we generate the confusion matrix of our model. We are using the TensorFlow.math library which generates the confusion matrix. A confusion matrix is a summary of prediction results on a classification problem. Here row represents the prediction level and column represents the real levels. Here the diagonally highlighted squares are the correct predicted number and others are wrong predicted ones. Now we plot our training and validation accuracy graph using epoch and accuracy. Here we observe that the accuracy is increasing with the number of epochs, and then we plot our training and validation loss graph using epoch and loss, and here we observe that the loss is decreasing with the number of epoch. For LDA the graphs are not so good, but for LCA our plots are quite good. Here is an analysis of density reduction algorithms for different datasets in a chart, and here it is observed that NCA gives better accuracy every time. It is an analysis of our model with previously established model. We can see that the accuracy of our model is less than other models as we use density reduction in our model. As we know, CNN works better with a large number of features, but training that research a large number of features is computationally expensive, which takes more time. That is why we apply density reduction techniques to reduce the number of features from the data and then apply CNN, and we can see that applying NCA and density reduction technique give accuracy closer than other models with less effort and time. Okay, The impact of three-dimensional reduction approaches on machine learning algorithms, namely PCA, NC, and LDA, has been analyzed in our paper. The performance of our model informing NCA and dimensional reduction algorithm is better than that of PCA and LDA according to the results. While working with large number of data, if dimensional reduction is used to reduce the number of features, then training the data using classification algorithms like CNN, SVM, NNETC will take less time because of a small number of features. So we can say that in a fixed duration, more data can be trained. In future, dimensional reduction algorithms can be used for feature extraction, and also other classification algorithms or CNN architectures can be implemented for classification to get better performance. Here are the references used in our presentation. Well, this brings me to the end of my presentation. Thank you for listening. If you have any question, I would be pleased to answer them. Thank you. Hello.
Any
Thanks,
questions?
Hi, Majesha. One question. What will be a possible application of your research? It's very interesting. There are several languages. Do you have something in mind in the future?
Yes, we can use this in our national ID or something recognition process like NID verification of all. Some people are not familiar with English or other languages. They only know our national language, Bangla. That's why we can use this in those verification process. They can easily write how they used to do, and sometimes their handwritten language is not very clear. That's why we can use this system there to identify their language effectively.
Okay, thank you.
Thank you.
There is another question. Oh, okay, Majesha, I have one question, please. Could you be deeper about this algorithm NCA? Why this algorithm is better than PCA or NLD?
Why NC is better than NC is mainly an unsupervised algorithm, and I think that's why it's better with images. I think so.
Okay, thanks, Majesha.
Welcome.
There is another question? No? Okay, so thank you very much for your talking, Majesha. Thank you.
Thank you.
Thank you. Saurabh, please share your screen, and I'll let you know when you start. Just we are going to wait until your introduction. There is Saurabh Malik around here. No? Okay. Looks like we finish for this track.
No está, there is no Saurabh connected, so we finish this session.
So we finish for this track. We want you all at 2 p.m. Mexico time. Professor Elias Manjarres from Physiology Institute of our university is going to talk about augmentation effects in the brain produced by random noise stimulation, physiology, and clinical applications. So thank you very much. We'll see you later.
See you.